We already know how to solve quadratic equations 3 different ways. We already solved it by factoring. We solved it using the quadratic formula, and we solved it using by completing the square. We're going to be solving it by graphing tomorrow. But today will be just kind of like a lesson that's going to get us to that part. Today's going to be just graphing functions. Okay? We're not going to be solving. We're just going to be graphing. Okay? So tomorrow we're going to be actually solving by graphing. The homework's just going to be pure graphing. Okay? So here we go. So for today, graphing, what is that related to in regards to quadratics? Let me show you. In real life, you guys have gotten in something like this before, I'm assuming. Some of us. Or the Ferris here, they have some small ones, right? Little ones that just go around like that, right? All right. Well, guess what? They use quadratics. Yes, believe it or not, you're like, what? Even on roller coasters? Yes. You cannot run away from polynomials. Remember, I told you we're gonna make a movie. You're walking down the street and turn the corner and polynomial. Oh, anyways. No. Okay. So check this out. Let me show you how it relates. So look at this roller coaster and look at the graph it creates. So for example, when engineers get and they start doing their sketches for roller coasters or games that involve like throwing like Madden, when they throw the ball, have you seen the little curve it makes? All that involves quadratics. So therefore, if you're getting into gaming or any engineering jobs, you're going to need quadratics. Same thing for medical field. They also need quadratics, you name it. Many times they have to use quadratics to deal with distances. And also, you deal with exponents and equations with exponents in the medical field because bacteria usually multiplies exponentially. What that means, it multiplies kind of like this graph right here, but the other way around. It goes up like, it goes up like this, like a half a parabola. Does everybody see it? Like a half parabola. It multiplies exponentially. That's why in medical terms, quadratics are used in regards to exponential growth of bacteria. Yes?
So graphing, are we only going to graph that goes down?
Right now we're going to graph both ways, but I wanna make sure that this is a lesson that we're going to revisit. This is something you did last year. Last year your teacher showed you how to graph quadratic functions and cubic functions. This year we're going to extend from that. I just want to make sure you guys see a couple more things that I want you to understand before we get to the solving portion. Everybody with me? All right, so with that said, on your blank sheet of paper, write your objective, please. At the bottom left, it says, I can graph a quadratic function and determine whether a point is on the graph of a parabola. Yeah, at the bottom left of your Cornell notes, you're going to write the objective, I can graph a quadratic function and determine whether a point is on the graph of a parabola. Let's read it together. 1, 2, 3. I can graph a quadratic function and determine whether a point is on the graph of the parabola. Okay, write that down, please. So if you haven't labeled your notes, just make sure you label them at the top, title them Graphing Quadratic Functions. Graphing Quadratic Functions. Okay? So we don't need the Freire model. I just need you to pay attention. Here we go. So functions, quadratic functions. We already saw some of this, and we've been dealing with quadratics before. So let me just show you what the only subtle difference from one to the other are. Quadratic functions, definition. Two variable equations where the highest degree is 2. You're saying, wait a minute, that sounds familiar. Yes, because we used the same definition for equations, didn't we? Okay, let me show you examples. Quadratic equation, quadratic function, aren't they the same? The only thing that differs is that here is y equals 2x squared. This is f of x equals 2x squared. But both of them could be quadratic functions. Let me show you another one. Y equals x squared plus 2. This is f of x equals x squared plus 2. Let me show you another one. y equals negative 3x squared plus 1. This is f of x equals negative 3x squared plus 1. Any of these are quadratic functions, but when they present it like this, you automatically know that they're talking about a function. When they present it like this, they usually say on the instructions, graph the following function. Maybe because it's not as obvious that it is a function. Does that make sense? So it's just a wording part. You everybody hear that? So when you get to the part of graphing these, they're saying, so do we change this just to y? Yeah, pretty much. I mean, this is the same as this, isn't it? Yeah. Let me show you some non-examples. You don't copy this. You're just paying attention. Here's some non-examples. Y equals 3x plus 5 and y equals x cubed plus 9. So think about this. Why are these non-examples? Why are all these examples? Non-examples, examples, non-examples, examples. Okay, tell your neighbor why these are non-examples. Yes, the highest degree must be 2. This one, the highest degree is 1, and this one is 3. So basically, what we've been looking at, that it's 2 variable equations and the highest degree is 2. Isn't all that familiar? Yeah, right? When we covered quadratic equations, isn't it about the same thing? Look at that. Same thing, same thing, same thing. Anyways, you get the picture, right? You get the picture? Anyways, here we go. Steps. Check this out. Copy these down, please. We already know these, but just to make sure that we have them for this homework. Steps. Number 1, make sure the function is in y form or solve for y. Make sure the function is in y form or solve for y. Make sure the function is a y form or solve for y. Yeah, steps. It's steps. Okay. Step 2, bless you. Build an input-output table and add a domain of -2 all the way to 2. And we remember when we did graphing for linear equations, it was -2, -1, 0, 1, and 2. Remember that? Okay. Number 3, substitute values into the function and find the range. That means all y values. Substitute values into the function and find the range. And number 4, plot the ordered pairs and graph your function. Plot the ordered pairs and graph your function. Plot the ordered pairs and graph your function. Number 5, check if a given point is on the function by substituting. So I'm going to assign you 1 point where you need to check to see if it's on the function, and I'll show you how to do that. Okay, copy that, please. All right, as you're finishing up your notes, stuff to circle or underline to make it easy to remember. Step 1, solve for y. Step 2, build an input-output table. Step 3, find the range. Step 4, plot and graph. Plot and graph. And at the end, check. Fairly simple. Solve for y, build your table, find the range, plot and graph, and check. Solve for y, build the table, find the range, plot and graph, and check. Solve for y, build the table, find the range, plot, graph, check. Solve for y, build the table, find the range, plot, graph, check. Solve for y, build a table, find the range, plot, graph, check. Solve for y, build a table, find the range, plot, graph, check. Solve for y, build a table, find the range, plot, graph, check. Tell your neighbor the steps, please. So on your graph paper, once again, the big graph on the back. Yeah, on the graph paper on the left-hand side, write this down. Example number 1. Example 1. You're going to write at the top left of your graph, graph y equals 2x squared, and check 2, 1 is on the function. So we're going to graph this graph y equals 2x squared, bless you, and we're going to check if 2, 1 is on the function. So first things first, we need to graph it. Is that correct? Yeah. All right. So to do that, you already wrote this down. First step, it says solve for y. Is it already solved for y? Yeah, they already did that for us. Step 2, build an input-output table. Kind of like the warm-up. What did we do? Get a table going, didn't we? So over here on the side, I want you to get your table going. So we got x and y, and our domain is from -2 to 2. So I write -2 to -1, 0, 1, 2. Now if you want, you can use fractions or decimals in between. That's up to you. I know you guys love fractions and decimals. Yeah. Or you can just use these values, -2, -1, 0, 1, and 2. Okay. So, step 3, it says, find the range, which means we need to substitute the values of x into the equation and find our y values. So check this out. I'm going to rewrite my first equation. So instead of x, though, I'm going to open a parenthesis. And what is my first value that I need to input there? -2. So do that, please. Write that in. And be careful with these when you are simplifying. This is a common mistake that most of us made when we first got to graphing. Use order of operations. Even if you need to write it down, PEMDAS. So I need to start with parentheses. Can I simplify in here? No. Exponent. Do we have an exponent? Yes. What is -2 squared? 4. So then we get y equals 2 times 4. What is 2 times 4? 8. So y equals 8, and that goes right here. And if we plot that point, let's plot it. We got -2 and 8 right here. So plot your point and write your coordinates. So far, so good? Okay. Now, let's do it again. So you're going to rewrite this again, but instead of -2, what's our next value? -1. So go ahead and substitute that in there. And once again, use your order of operations. What is -1 squared? 1. So this is y equals 2 times 1. What is 2 times 1? 2. And that goes over here. And to plot our point is at -1 and 2 right there. And you write your coordinates. So far, so good. Next one, substitute 0 into the equation. So what is 0 squared? 0. So we get y equals 2 times 0. What is 2 times 0? 0. So my value here for this one is 0, and I plot my point at 0, 0, which is the point of origin, which is right there, and you write your coordinates. Yes, for right now, yes. I want to make sure that you understand what you're plotting and what you're doing. Next one, we substitute 1, and 1 squared is 1, so 2 times 1 is 2. And that goes here, and if we plot our point, 1, 2. And our last one, we substitute 2 into the equation. So that becomes 2 times 4, and 2 times 4 is 8, and that goes here, and we plot our point, 2, 8, which is over here. We write our coordinates, and we already plotted our points, we graph our function, so here we go. Okay. So far, so good? All right. So, like I said, this is something fairly easy because we already done it with linear equations. Now we're doing quadratic, but the same process. However, first part, graph. Second part, what are they asking us to do? Check. We're going to check and see if this point is on this function. So before anything else, pens down really quick, eyes up here. This is what I want to make sure that you understand. Sometimes they're not going to give you a graph such as this for you to graph the function. They're only going to give you enough space, and it's going to say, check and see without graphing if this point is on the function. Let me show you how that's done. To check if this is on that function, we need to substitute these two values into our original equation. So that means instead of y, I'm going to open up a parentheses, and instead of x, open up parentheses. We know that once we are given a point, which one of these is x? 2, and which one is y? 1. So all we need to do is substitute these values in here. Y is 1, x is 2, and then we just simplify it. So what is 2 squared? 4. So we bring everything else down. This is 1 equal to 2 times 4. What is 2 times 4? 8. Is 1 equal to 8? No. If this is not true, then this point is not on this function. Everybody understand that? Okay, copy that, please. Fairly simple. It's not that difficult. We already did it before with linear equations. Now we're doing it with quadratics. Copy that, please. Now check this out. So if they ask you, without graphing, is this point on this function or on this graph? You substitute values, and if it's not equal to this, then therefore it's not. Now, another way of looking at it is like this. If they give you a graph to graph the function, and then they say, is this point on the graph, but they don't specify for you to check without graphing, can't we just plot the point and check? Yeah, right? Where's that point at? 2, 1 is about right here. So is that point on the graph? No. Is this point on this graph? No. So therefore you would write this point is not part of the function. Yes, if you want. Yes. If I ask just is this point on the graph and I don't specify, you can do it either way. Okay. The question was if we have a party and I ask is this point on the graph, do we need to graph? No, you can do it either way if I don't specify. Okay. So now observation. Check this out. I want you to make this note. Asterisk. Write this down. When the LC, what does LC stand for? Leading coefficient. Look at this leading coefficient. When the leading coefficient is a positive, when the leading coefficient is a positive, the parabola opens upward. The parabola opens upward. Everybody look up, please. So y is equal to 2x squared. Look at the leading coefficient. It was 2, a positive, and look, it opens upward. Everybody there? The second observation, I want you to circle this point right here. Point an arrow to it, and we're going to label that the minimum. Minimum, also known as the vertex. Vertex. Now check this out. If we were on the roller coaster and all of a sudden it took a dip, what would be the minimum height? It would be down here. Is that correct? That's why from now on, whenever you see a parabola like this, this will be the minimum, also known as the vertex. Are we there? Okay. Yes. We're going to do one of those. Okay. So here we go. So with that said, steps. Was it solved for y? Yes. Build an input output table? Yes. Domain -2 to 2? Yes. Substitute values and get our range? Yes. Plot and graph? Yes. And check for the point to see if it's in the function? Yes, we did that. Any questions? All right. Copy this one down. Now you can turn your paper over in the back. You have more graph paper. Example 2. Example 2, you're going to write graph y equals -2x squared and check if 1, 1 is on the function. Graph y equals -2x squared and check if 1, 1 is on the function. See if you can do this one completely, all the way through. Go. Okay, as you're finishing up, here it goes. Is it in y form? Yes. Solve for y. Yes. From there, I get my table going. -2, -1, 0, 1, 2 for my domain. My range, I substitute these values in here. My first value becomes -8. That goes here. I plot that, -2, -8. Move this over. It's down here. There it is. Okay. From there, next value, I'm going to substitute -1. So therefore, that becomes -2. So -1, -2 is about right there. Next value becomes 0. So that is right there. Next value becomes 1, -2, which is right there. And the last one becomes 2, -8. Is that correct? That's down here. My parabola, there it is. And to check, to see if this points on this function first without graphing, check this out. So I'm going to go ahead and substitute those values in the equation. So here goes 1 and here goes 1. So what is 1 squared? 1. So this is -2 times 1, which is what? -2. Is 1 equal to -2? No, therefore this point is not on this function. This is one way of checking it. What's another way? By plotting it, right? Where's 1, 1 at? 1, 1 is about right here. So is that on the graph? No, here's my graph. Here's the point, and it's not on this curve. Everybody with me? So that's not part of it. Now check this out. Make a note for yourself here. Asterisk. When the LC, tell your neighbor what that is. The leading coefficient is negative. The parabola opens which way? Downward. Okay? Second observation, circle this spot right here. You're going to point to that, and that's called the maximum, also known as the vertex. Maximum, vertex, which is this spot. Now check this out. If this was a roller coaster, everybody look up. If this was a roller coaster, it goes, what is the maximum height? Up to right there, is that correct? And then it goes down. That's why, that's an easy way to remember. So check this out. This, when it goes this way, this will be the minimum height, and this will be the maximum height. Are we there? So that's an easy way to remember that the vertex could either be the minimum or the maximum. Any questions? Okay. Minimum. Okay, here we go. Yeah. Not sideways right now. Then it wouldn't be a function. I'll let you know, but not right now. Here we go. Let's move on. Last example. Give me a second. Everybody look up, please. Pens down, eyes up here. Okay. Now, if I was to give you this to graph, let me just show you what it's going to look like. Here's my table. Substitute values in there. You're just paying attention. Paying attention. Here it goes. There's my graph. Okay. Now, here's the observation. Pens down, eyes up here. Stop what you're doing. Here it goes. Notice the first two examples that I gave you. Does it have a constant at the end or a number by itself? No, and it crosses at 0, 0. Let me show you the next one. Did it have a number at the end? And it crossed at 0, 0. Does this one have a number at the end? And where does it cross? That's why this is also known as a y-intercept. Remember that? When we started doing the quadratic, solving quadratics by factoring, I had you guys plot the 2x values and the y-intercept, and there's the parabola. Everybody with me? All right, and the same. Check this out. This is a positive leading coefficient, and where did it open to? Upward. Everybody with me? So, for homework, just double check. Make sure that we understand. We need to graph and check if a point is part of the function. The homework will be found on pages What number are they? 548, 549, numbers 1 through 41 odd. Have a good one, guys. Turn in your progresses and homework over here. Enjoy your homework. I'll see you guys tomorrow.